All right, so the other one I wanted to review was 4C because this is a problem where you have the x in the, you have an x in the, or you have a variable rather in the exponent as well as in the base. And this was a problem that students always find tricky because there's a couple of steps involved. And the first step is going to be a little bit of algebra. So the first step is to rewrite that x to the power 1 over 1 minus x as to change the base, essentially. So we change the base from x to e, and you can check that this equality is true, right? Because e and natural log are just inverse functions, so they just cancel out, and that gives me that this equality is true. But by doing this, we can rewrite the function a little bit, and we can pull this exponent out in front of the natural log, and that gives me an expression that looks like this. Okay, so we rewrite our limit using that algebra. So we rewrite this term as e to the power ln x over 1 minus x. Okay, so far so good. That was the first step. And now the next step is actually to understand the limit of the exponent. So let's try that. So the limit of the exponent, well, as x goes to 1 from the right, ln of x is going to 0, and the denominator is going to 0 as well. Indeterminate, apply L'Hopital's. We get 1 over x for the derivative of ln, and then just -1 for the denominator. And so this function is, just continuous at 1, so we can just plug in 1 and we get -1. So as far as indeterminate limits goes, this function is actually pretty straightforward to compute using L'Hopital's rule. But we're not done because we have to go back to our original function. And now we understand that this is just going to be e to the power, like, remember what is the limit here? So this term limits to -1, right? That's what we did down here. And so if we go back to our original function, the answer should be e to the power -1, and we're done.